Now, what do you think a graph of cos or sine is going to look like? Your textbook suggests that you think about a Ferris wheel. This Ferris wheel has to rotate in the anti-clockwise direction because we always measure angles, remember, starting at 0 here and then increasing as it moves, as it rotates. Think about cos. Cos of theta, cos of the angle, is the x-coordinate of the point as it goes around. What's happening to the x-coordinate as it moves around the unit circle? Well, it's going to start at 1 over here, and it's gradually going to go back towards 0 up here. X-coordinate is 0. Then the x-coordinate is going to go further back until it's -1 over here. Okay, cos is the x-coordinate. Then it's going to gradually go back towards 0 again. Down here, the x-coordinate is 0. And then over here again, x-coordinate is 1 again. I'm actually going to use the graphics calculator to capture the data and show you what this looks like. As well as showing you, you're going to see how to use this graphics calculator to do some pretty clever stuff. So this is my unit circle program, which I've showed you before. And we're trying to think about the x-coordinate, which is cos theta. Starts at 1 over here and gradually decreases towards 0. I'm just going to stay in the first quadrant to begin with. It's also the position of that blue vertical line going gradually towards 0. What's the shape of that curve going to look like? Well, what I can do is get my graphics calculator to capture the coordinates as I drag it around. Let me show you how to do that. Right-click on the point and say coordinates. Now I have those coordinates, and I can actually give them names. See, those coordinates change as I drag the point around. I'm going to call them names. If I click on that, and then, oops, I've got to go to the calculator, and then I go store up above var. If I go store that into point coordinate for cos. So my x is cos. And this one here, I'm going to store into my point coordinate sine. And I believe I've already got a variable for this one, which is theta. So, if I add a new sheet, Control Doc, which gives me a new page, sorry, not a new sheet, new page, I want a list and spreadsheet. And in this variable, I'm going to capture that one. So I'm going to go Menu, I want to Data, I want to Data Capture Automatically. I want to capture the theta. All right, that's the angle. Now on this one, I want to capture Menu, 3 for Data, 2 for Data Capture, Automatic. You can actually see the format of what I have to type. I might just type it for the next one. Point coordinate cos. And here I want to capture point coordinate sine. You can see it recognises the variable. It turns it into bold for me. So far that's not very interesting. I've only got one point. But watch what happens when I go back and drag this around. I'm just dragging it around in the first quadrant to capture all the different locations it could go. When I go back to my spreadsheet, it's actually automatically, that calculator's automatically recorded for me all those coordinates. Now I'm going to plot them. So this one, the way the calculator works, I have to give it another name as well. So this one is called angle. I can't call it angle, let's just call it angle, ang for angle, x coordinate and y coordinate, which remember is cos and sine. Actually, it might even be helpful if I called it that, mightn't it? Cos coordinate and sine coordinate. If I now add a new page to display that data, down the bottom I want to go against the angle, And then up on the side, I want to have a look at cos. And there is the shape of my beautiful cos curve. It's heading this way, started at 1 and heading down towards 0 at 90 degrees. What happens if I go past that into the second quadrant? What did we say? How far was it going to go? It's going to go down to 0. Then it's going to go negative. Remember, we're just looking at the x coordinate here. It's going to go negative towards 1. Sorry, negative 1. In the third quadrant, it's going to come back towards 0. And in the fourth quadrant, it's going to go back towards positive 1. Let's go have a look. It hasn't fixed my graph for me. I wonder if I do this again. There we go. That's the shape of the cos curve. Now what do you think the sine curve is going to look like? Let's have a look back at our Ferris wheel again. The sine curve is the y-coordinate. The y-coordinate is going to start at angle 0. The y-coordinate is 0. As we go around, the y-coordinate increases up to 1. Then the y-coordinate goes back down towards 0 and down towards negative 1. At 270 degrees, it's negative 1. Whereas cos at 270 degrees was 0. Let's go back. At 270 degrees, cos was 0. Let's have a look at sine. I don't even have to recapture the data, it already has. I want to change the page layout. Page layout. Select layout this way. Here, data and stats. That's better. So down here, I want the angle, and up here, I want the sine. And that's what sine looks like. So cos starts at 1, goes to 0, goes to negative 1, goes to 0, goes to 1 again. And sine starts at 0. Let me remind you, sine, the y-coordinate starts at 0, increases as I go to the top of the Ferris wheel, goes back down at 180 degrees, it's 0 again. Should be. It's hard to see under the hand there. 180 degrees is pretty much 0. At 270 degrees, it's negative 1. It's at the bottom of the Ferris wheel. Then it goes back again. Now, actually, these graphs cycle and keep on cycling because we could go around and around this Ferris wheel again and again. And there's no problem with my having an angle bigger than 360 degrees. And that's going to come up later. But there's the basic shape of the sine and cos curves. The textbook actually has a nice diagram here. So let's go to cos that we started with. Okay, cos starts up here, goes down, goes up again, and it just cycles on. Sine starts at 0, goes up first, then goes back down.